In this video we will show that the integral from 0 to infinity of square root of y times e to the minus y cubed dy equals with a square root of pi divided by 3. We will see this interesting problem. First we need to do a change of variable w equals y to the power of 3 dw dy, we change the differential 3y squared, and from here dw equals 3y squared dy, dy equals dw divided by 3y squared. Now here y should be w to the power of 1 divided by 3, w to a third, so dy becomes dw over 3, and here you have in the denominator w to the 2/3. My differential dy is a third times w to minus 2/3 dw. I can change the bounds of integration for y equal to 0, w equals to 0, and from y tending to infinity, w goes to infinity. So I'm okay with it. The bounds of integration. Now the integral will become from 0 to infinity square root of y is w to a third power, like that, e to the minus w, and I change the dy with this expression here. This is w to the power of 1 over 6 e to the minus w times a third times w minus 2/3 dw. I can pull this out because it's just a constant, does not depend on the variable w, and I have the integral from 0 to infinity w to 1/6 minus 2/3. Here is the apply the laws of indices, e to the minus w dw. Now I need to have a common denominator here. Minus 4 divided by 6 e to the minus w dw. This is w minus 3/6, 3 over 6 e to the minus w dw. I can simplify this fraction, so it is w to negative power of 1 divided by 2 e to the minus w dw, and this I can write it in the following way: w to the power a half minus 1 e to the minus w dw, so it's a third times gamma, this is gamma of a half, so it's a third times square root of pi. Gamma of a half is the square root of pi, so what I obtain is square root of pi divided by 3. As a consequence, I have obtained the desired result. Square root of y, the integral from 0 to infinity, square root of y e to the minus y3 dy equals square root of pi divided by 3. By using a method of substitution, changing the variable from y to w, I change the variable, then I do change the differential in the bounds of integration, and then I use the gamma function here in order to find this value, which is square root of pi. So it's a nice problem combining the change of a variable and employing the properties from the gamma function.